Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, subscribers, viewers, students, and future engineers. Here is another problem in Vitamath. This is a challenging problem, and those who are graduates in engineering can relate with this, can solve this, as well as those who are through with calculus. If you want to anticipate the solution to this problem, you can by pausing the video, especially those who are challenged. So for the region bounded by 9y equals x squared, which is a parabola open upward, x equals 3, which is a vertical line 3 units to the right of the y-axis, and the x-axis, which is y is 0, horizontal line, which is the x-axis. Determine the following: the area, the centroidal coordinates of area, the volume when the region is revolved about the x-axis, the volume when the region is revolved about the y-axis, the volume when the region is revolved about the line. 2x minus 5y minus 10 equals 0. These problems may be solved without purely integrating, especially if you know the formulas. But in this case, I'll use integral calculus, and let's just check the the answers by the shortcut, if you know the shortcut. So for the figure first, you may have point plotting if you're not familiar with this, but this is a parabola that is open upward, and you may plot points when x is 1, y is 1 over 9, when x is 2, 4 over 9, 3, 1, like here, when x is 3, y is 1, when x is 2, y is 4 over 9.444, so that's somewhere there. So this is the graph of the curve parabola 9y equals x squared. Then this is the line x equals 3, 9y equals x squared. This is the line, inclined line at part E later. So this is the line x equals 3, so this is the shaded area. And let's have that vertical strip. You may have horizontal strip if you want, but in this case, the vertical strip is simpler in expression than the horizontal strip. If you have horizontal strip, then this distance is x sub c is just x, and this is 3 minus x because that's 3 units. And the variable of integration for horizontal strip would be y. In this case, it is x that is the variable of integration. So the height is just y because upper y is the y of this parabola, lower y, the x-axis, is y equals 0. So it is just y. Then the thickness dx, that's x sub c, which is just x, the location of the centroid of the strip, for the location of the centroid of area later, or volume, or for part B. So this is, if you consider horizontal strip, then that is 3 minus x dy. So when this differential area is revolved about the x-axis, it will generate this circular disc. So the differential volume is area of circle times thickness. If you revolve it about the y-axis, it will generate a cylindrical shell later. But let's proceed to the first problem first. So area equals integral of dA, and differential area is the area of this strip, which is just base times height, or dx times y, or y dx. So area is integral of dA, integral of y dx. The variable of integration is described by the differential, so it is x. So x varies from 0 to 3. So you have limits here 0 to 3, y dx, and y is equal to x squared over 9 dx. You may have your calculator because this is supposedly calculator aided, but for beginners, if calculators are not allowed, then you have to apply power formula. So we have x cubed over 3 times 9. So x cubed over 27, 0 to 3, 1 over 27, quantity, upper limit, so 3 cubed minus 0 cubed. So that's 27 over 27. So the area is 1 square unit. The shortcut is this is a spandrel of parabola, complementary parabola, 1/3 of base times height. The base is 3 units, the height is 1 unit. So area is 1/3 of 3 times 1, so that's why it is also 1 for checking purposes. Then for the centroidal coordinates of area, we use Varignon's theorem. So, or first moment of mass, that is area times barred x, the moment of area times about the y-axis times barred x, is equal to the sum of the moments of this component, and the component is this strip. The area is dA, and its distance from the y-axis is x sub c, or simply x, because every element of this vertical strip is equidistant from the y-axis. So even if it is this centroid here, the distance is x, just x. X sub c is just x. So area is 1, barred x, integral from 0 to 3. X sub c is just x, and dA is y dx, x squared over 9 dx. Integrating, that would be x cubed. So x cubed integral is x to the fourth. 4 times 9 is 36, 0 to 3. So 1 over 36, 3 to the fourth minus 0 to the fourth. 81 over 36 is 9 over 4. Similarly, the location of the centroid of the strip is here, so the height is y, therefore y sub c is just half of uh, y, so it is y over 2. Y sub c for horizontal strip is just y, but in this case, considering vertical strip, of course the centroid of the strip is there, half of the height, so half of y is y over 2. So that's why 1 times barred y equals integral 0 to 3. This is y sub c for this vertical strip, which is half of y. Then differential area y dx. So 1 half y square. Y square is now x square over 9 quantity square dx. So 2 times 81 is 162. Integral of x to the fourth is x to the 5 over 5 from 0 to 3. So 162 times 5 is 810. Barred y therefore is, because the area is 1, so quantity 3 to the 5 minus 0 to the 5. So barred y is 3/10. Therefore, the centroid of the area is at quantity 9 over 10, 3/10. The shortcut is, if you can remember, along the tangent, the location of the centroid is 3/10, barred y rather, along the tangent, 3/4 of 3 for barred x, so 3/4 of 3 is 9 over 4. Then from the tangent to the vertex to the centroid, it is 3/10 of the height, 3/10 of 1. So 3/10 of 1 is 3 over 10. That's why we arrive at these answers here. But if you want to know that it is really 3/10, you look at the derivation in statics. I derived this location of centroids in general in statics. You just find that video there. Part C, the volume when the region is revolved about the x-axis. So when this region is revolved about the x-axis, it will generate that shape. But considering the strip, it is this is the strip, and it will generate this cylindrical disc, which is the differential volume is pi radius square, which is pi y square. The thickness is dx. So v sub x is integral of differential volume about the x, which is area of the circle pi y square. I hope you can imagine. Then thickness dx. So volume about the x-axis is pi integral 0 to 3 of quantity y square, x square over 9 square dx. And that is pi over 81. Integral of x to the fourth is x to the 5 over 5, 0 to 3. So pi over 405, 3 to the 5 minus 0 to the 5th. Simplifying, that's 3/5 of pi cubic units. Now, the other way is you apply Pappus theorem. The area is 1 times distance traveled by the centroid, which is 2 pi times 3/10, because barred y is 3/10. Where is that? This one. So v sub x is area times distance, and distance is circumference, 2 pi barred y. So 1, 2 pi barred y, and that's 3/5 of pi. So the same as this cubic units. Similarly, when revolve about the y-axis, it will generate a cylindrical shell as shown. This blue here. Then if you cut that, then flatten out, the length is the circumference, which is 2 pi times x. I hope you can imagine. It is just a rectangular plate. The height is still y, that one, and the thickness is dx. So I hope you can imagine. Imagine a cylindrical shell, like the lateral part of the cylindrical can, excluding the top and the bottom. Then cut it vertically, flatten it out. It will look like a plate, rectangular plate. So the length of the plate is 2 pi x, so that you don't need to memorize. The height is still y, and the thickness is dx. That's why v sub y integral 0 to 3 2 pi x times y dx. Substituting the value of y, so we have 2 pi integral 0 to 3 x. This is y, x squared over 9 dx. So 2 pi over 9 integral of x cubed is x to the 4th over 4, 0 to 3. We get pi over 18, quantity 3 to the 4th minus 0 to the 4th. So simplifying, that's 9 pi over 2. If we cubic units, if we apply Pappus theorem, then it is area times 2 pi barred x, because this is the centroid here. It will generate a circle, and the length of the circumference of the circle is 2 pi barred x. So area is 1, then 2 pi barred x is 9 over 4 here. So we get 9 pi over 2, which is the same results as this, cubic units. And finally, the volume when the region is revolved about the line 2x minus 5y minus 10. So we use Pappus theorem here. This is the line 2x minus 5y minus 10 equals 0. Then the centroid is there. It will generate another circle, and we have 2 pi times distance. The distance from a point to a line from analgem is simply absolute value of a x1 plus by1 plus constant over square root of a square plus b square. And you can have that, or you get the slope here, so that you don't need to memorize. Then there is centroid there. It is perpendicular to here, so you just define a right triangle in order to analyze that distance. But this is the direct formula. It will extend the video if I'm going to solve it in that manner. I will just leave it to you. You know the centroid. You can find the angle here because the slope is known. and it is for graduates of engineering, so you should be able to know the slope and the angle of inclination. The angle between that point and this the line perpendicular to this line and the vertical is equal to the angle of inclination. But I'll just use this formula here, and this is derived also in engineers in progress, to be derived in engineers in progress in the future for distance formula from a point to a line. So A is 2, x1 is the centroid 9 over 4, then minus 5, y1 is the y coordinate of the centroid, then the constant minus 10 absolute value over square root of a square 2 square plus negative 5 over 2 square. So it is 7 over square root of 29, that's 1 point something. Then substitute volume equals area times 2 pi times radius of revolution, which is in this case that distance d, and we'll get in decimal 8.167 cubic units. So that's it for this video. I hope that you were able to recall concepts in calculus and especially Pappus theorems or propositions. And for those who attempted to solve this problem by their own, then I hope that you got the same answers.